You can use that to either improve your robot design, you can improve how you can think about the competition manual and the rules, or also how you can use it to improve performance as well. So the first thing that AIs use a lot of right now is computer vision. So just by a show of hands, how many of you guys have seen the self-driving car taxis that have been around? Yeah, there's a few. So it's this whole thing, Waymo. They're in a few cities, and they have a lot of these sensors, but they also have cameras as well, which they use to find their position in the world and see how they're going to drive around. And so this is an example of just how computer vision and machine learning is used in the real world. And so now how can you guys do something similar like that with your robots to make it more autonomous and more intelligent? So one of the cool things, there's a few different options here. The first one here is Limelight. There's also Husky Lens. And of course, you can just use normal camera. But to go through these, going from the most expensive to the least expensive, Limelight, it has absolutely everything you'd ever need when it comes to needing computer vision, all in one package. It processes it completely on the Limelight, which means it's going to be a lot faster for getting information back to you, so that it's going to be more accurate. It is a lot easier to use. So let me go back to what it looks like. That's what it looks like. It's relatively small. You plug it into the USB port on your control hub, and that's how you can use it. It uses OpenCV under the hood. They also have neural networks built in as well. So that means you can feed it a ton of images of some kind of game object. So for last year, you could feed it samples, and it would recognize what a sample was, maybe what color it was, or where it is, just based off of the information and compute inside the Limelight. But also, if you want to do something more simple, you could just do what color. There's a big blob of blue. That's probably a blue sample. Husky Lens is very similar. The Husky Lens itself does processing on on the actual lens as well, so you're going to get that same benefit of the co-processing where it's not being done on the actual control hub, but rather here, faster reads, more accurate results generally, but it is mostly OpenCV. So you're going to have to program it directly on there. There isn't as much neural network options. It's not as FTC friendly. The Limelight is designed specifically for FTC, or the Limelight 3A specifically. And finally though, there is just some webcam. You just plug it into the control hub and you can use it. So one of the disadvantages, the main disadvantage, is that the processing itself is done on the control hub, which means if you have some really complex OpenCV pipeline, which is just taking away all the colors except for blue, or maybe finding the circumference of some kind of object and stuff like that, then in that case, it's going to be a little bit laggier, you're going to get slower results, and it could slow down your robot. But in general, anything you could do on Husky Lens or the Limelight can very easily be done on this as well. There's no limitation when it comes to what you can do. OpenCV is the same version on the control hub that you use on the Limelight. Just one anecdotal thing that I can say about using just a camera versus a Limelight. There was a team I saw at an event up a creek, and they used this exact camera. It was a Logitech C720, and they had a gradient descent model. So in center stage a few years back, they predicted where they would place those pixels, or the mosaic pixels, right? Yeah. Pixels on the field or on the backboard. Completely on control hub. There was no co-processing. It was done completely on the control hub. They made it fast. They made it efficient. And it was really good, They were one of the best teams in the world because of that automatic placing. And so they did that completely on the control hub. So when it comes to limitations with FTC, you can generally do anything you'd need on the control hub. The other options do make it easier, though.
What do you mean when you say OpenCV?
OpenCV is a library that has been designed by plenty of people, and it's been ported to FTC specifically. It's included in the Java SDK that you use. And you create pipelines, is what they're called, and those process images. So it takes one image, processes it, and spits out another image and related data. So you could say the position of a circle in the image, or the position of whatever it might be. That's how you would use OpenCV to do whatever you might want to do. Also included in OpenCV and generally used in the wider space are April tags. So a really cool thing about April tags, you might have seen these in stores or just other general places. It looks like a QR code. It's not, but it kind of works in a similar-ish manner. The way it's designed is you have a lot of black and a lot of white. And so it's supposed to be easily recognizable by a camera. So the camera can say, hey, I know where this is. It's easily, you can see what type it is. And then what you can do with April tags is they tell you exactly where they are in the world. So a cool thing about April tags is as long as you know where that April tag is in the real world and you have a camera that is properly tuned, then you know exactly where you are, as long as you can see that April tag. Or if you know exactly where you are, you can tell exactly where that April tag is. Either or. The requirement for an April tag is you either need a position for the April tag or the position for yourself. And again, this can be done with OpenCV as well, and the other two cameras as well. So OpenCV can do both of these, and April tags in general are an incredibly great option for for visual localization, as mentioned there. So visual localization is like odometry in the sense that it'll give you a position on the field at all times, as long as you have visual of at least one April tag. And so if you aren't able to get odometry for whatever reason, you can just get the your C720 camera, no issue. And as long as like the C720 and I believe another camera are automatically tuned for you. So all of the tuning that you normally have to do is done for you, and you can use that camera, and it'll generally tell you where your robot is, so long as it can see one. Other usages of visual computing in FTC would be detecting game objects. So in the previous year, samples, lots of teams detected where the sample was, and they'd have a claw that would go down and grab it. And so the really nice thing about that was you wouldn't have to think of where your robot was or what you had to move to grab one. You just drive into the sub, press a button, it'd grab it, and you could score it. No issue. It alleviates a lot of the requirements on the human driver, since it allows it to do more accurately, and also, in general, a well-tuned computer is going to be more accurate and faster than a human, which allows you to do that. So if you're able to detect game objects, then you can do a ton of different things. So in the previous year, again, Upper Creek, wow. They had an automatic grabber, as well as they scored up to 10 specimens in auto. Why? Because they were able to easily grab and place automatically. There was no guesswork. They didn't assume that where they knew anything was. They check everything manually. Yes?
So if I was a brand new student to FTC, whether I'm on a rookie team or not, how would you suggest I got started doing things like this?
Yeah, so one of the great things about the SDK is it has a ton of samples. And so they have this is actually from I cut off part of the picture, but this is actually from the OpenCV sample that first provides. And so it will detect, in general, a kind of blocky object, and it'll block it out. So for this kind of rectangular object, it probably finds this shape inside of the box, and then it'll see, hey, it's rectangular shaped, put the tightest possible box on there, and now that you have the tightest possible box, you can get an angle based off of that rectangle, and you can do stuff. In general, the best way to learn is just to play around with stuff. And so go through those samples, see what's working, what's not working for you, and then just try changing stuff. If something's not working, try changing stuff and see if you can get it working. In general, just detecting stuff is a way to improve your efficiency and accuracy in games. And also, you can think back to past games, how vision was used. The sky's the limit for visual anything. In general, be creative. There's plenty of options to use. All right, so I'm going to move on to something I actually did over the summer. So this is a AI competition manual assistant, and so this is the phone view because it fits a lot better on the slide. But in general, you're able to go to this website, which I'll share in a second, and you can ask it a question, and it'll generally respond to that. One thing is, it doesn't show here, but there's an acknowledgement that says this is a chatbot. It's not going to give you any answers you can use as rulings. It's not something you can go up to a ref and say, hey, my phone said this. It's not how it works. But it will provide sources, which will take you to the actual manual, which then you can use as official rulings. So in general, what this competition manual assistant can do is, if you're not familiar with the game, hey, what, like for in the previous year, what are samples? How do I make a specimen? How can I score? Those are questions you can ask this chatbot to better understand this upcoming Decode game in an easier manner than just reading through all like 150 pages of the manual, since it is a dense document. Although I do recommend very much reading the game manual, as there is nuance that won't be carried over to the actual responses. In general though, if you have a quick question like, I got hit like last year, there was a penalty, a rule called G427, where if you were trying to ascend and you got hit in the last 30 seconds, the other team would get a major penalty, a major foul, which is 15 points, and you would get an automatic level 3, which is 30 points. But if you didn't know that rule existed, and you came to the spot and said, hey, I got hit while I was trying to ascend, they knocked us over, we weren't able to, and you ask it that, it'll tell you, hey, there's a rule called G427. And then it'll take you to that link, you can read the actual rule itself, and then from there, you can go up to the ref, or the head ref, and whatever, go to your question box and say, hey, here's this rule. Did I interpret this right? And then you can go from there. Just in general, remember that it can make mistakes, and it is specifically for FTC. So if there's any other things that you can ask, it won't particularly work. So, there we go. So this is, oh man, it lagged. Okay, so this is a link to the actual chatbot itself. That being said, this is not updated for the official game because the game hasn't dropped yet. But it should update around, well, once the game reveals, it'll be pushed. It'll take maybe a few minutes to update, but once the official game actually releases, then you can use this and try to ask it questions about the game. But right now, it's not going to provide you an answer about the game that hasn't released. Yes?
Is this a closed LL system like Notebook LM, or is it open source to the internet, or is it
So
source-based?
it's closed. So it's trained specifically off of the competition manual itself, and in general some other documents that were found to be beneficial.
Is there a list of all the sources that it's feeding off of?
It'll provide, right now when it gives you an answer, it'll provide you a source from what it got. So if it used the competition manual, it'll provide you a page and it'll take you to that competition manual. I know I went over a lot. Any other questions?
No, I was gonna say, how long did it take you to develop that? Because that's really cool. Yeah.
Man, so the back end, like the actual AI part, didn't actually take too long. It was about a month and a half. But I ended up doing all of the front end work as well as also deploying it to AWS and all the nitty gritty stuff. And that took much longer. So I wasn't familiar with front end or deploying to the web properly. And so that took a long time. I got it like officially up and running 20 minutes ago.
Wow.
Any other questions about it?
Not really a question, but more of a comment. I'm just now learning. I'm not an expert or anything on vision, but I'm just starting to teach myself some of it. I noticed on the camera that we're using an example with the blocks, where it's at an angle,
Yeah.
that the camera frame rate was like, or the resolution was 320 by 240, where the camera is usually 640 by 480, I think. So you've narrowed it down so your bandwidth is not that high, so you get more processing frames per second.
Exactly.
Also, one thing that I've learned is that you have to hit refresh to see that picture. And the kids, when they first see that, it's like, well, this is ridiculous. I should see like a video of this. If you take your HDMI cable of a television or a monitor and stick it in the control hub itself, you can get that live feed of that camera feed.
Yep. That's a great thing. That actually reminds me. There's a FTC library that you can use called FTC Dashboard, and I believe now there's a new one called Panels, right?
Yeah.
So there's two open source libraries that you can use, FTC Dashboard and Panels, and on those libraries it'll give you a live feed of the camera on your laptop, so you don't have to be plugged in or anything, and that'll allow you to see it, update in real time, as well as if you're, pushing location data, it'll also show you the field with your robot on that field as well. And so there's a lot of usages for that, specifically for tuning these kinds of these models. If you're trying to detect a certain color, you have to like make a small change. You don't want to make a small change and push it. So FTC dashboard and panels allows you to make those changes instantly and not have to update the actual app every single time to iterate much faster. So thank you for saying that. That did remind me. So if you guys want to iterate faster, FTC dashboard and panels are great options.
Are there any tutorial videos that people could find?
Yes, there's a lot. I know there's one dude I've been seeing a lot. I think it's Coach Pratt, if I remember correctly.
Yeah.
Is that's Coach Pratt? Okay. And so he's honestly had a ton of really good videos, high quality videos off of just FTC in general. And it's not specific to vision and artificial intelligence. It's the entire FTC. And so anything he has is going to be high quality. In general, if you do look up FTC space and then whatever you're looking for, you're going to probably get something pretty good. I know there's been a lot of good tutorials for OpenCV. OpenCV isn't specific to FTC, so any OpenCV tutorial you find, whether it's in Python or Java or C, will translate. It's the same kind of concept. It's the same pipeline idea. It's the same stuff. It's technically the same library. It's just ported to a different language. So.
We've got about a half hour before we can show you the kickoff video.